June 2018, question number 6. It says, in this question, take the value of pi to be 22 over 7. It says the diagram below, not drawn to scale, shows the cross section of a circular metal disc of radius 21 millimeters. A square hole of sides 6 millimeters is located in the center of the disc. Alright, we're asked to calculate the circumference of the disc. We're asked to calculate the circumference of the disc. So, circumference C is equal to 2 pi r. So this is equal to 2 times 22 over 7 times the radius, which is 21. Alright, so 7 into 21 goes 3 times. So this would be 2 times 22 times 3, which works out to be 132 millimeters. Alright, the next thing we should do is we're asked to calculate the area in millimeters square of the cross section of the disc. Alright, the area in millimeters square of the cross section of the disc. Alright, so the cross section of the disc is actually a circle with a square hole in it. So therefore we have to take away the area of the square from the area of the entire circle. So area of the cross section is equal to area of circle minus the area of the square. So the area of the circle is pi times radius square. So that's 22 over 7 pi times the radius, which is 21 times 21. And this is minus 6 times 6, which would give you the area of the square. So this turns out to be 1386 minus 36, and the area of the cross section is 1350, and that is millimeters square. All right, so 7 here, cancel here is 3, so it's 22 by 3 by 21, 1386 minus 36, the answer is 1350 millimeters square. All right, so let's see what's next. All right, so next we're told, given that the thickness of the disc is 2 millimeters, calculate the maximum number of discs that can be constructed from 1000 cm cube of available metal. 1 cm cube is equal to 1000 millimeters cube. So what they have available is a total of, or the available metal is a total of 1000 centimeters cube. All right, so available metal is equal to 1000 centimeters cube, which is equal to, now 1 centimeters cube is 1000 millimeters cube. So 1000 centimeters cube is 1000 multiplied by 1000, which is 1 million, and this is millimeters cube. So available, the amount of metal available to make disk is 1 million centimeters cube. All right. So that is what volume. So let us now determine the volume of one disk. Volume of one disk would be equal to A times H, where A is the area of the cross section and H is the height. The cross section, the area of the cross section was 1350. We got that from the previous section of the question. And the height of the disk, or thickness in this case, is 2. All right. Let me see if I probably could get just a quick sketch of the idea of this disk. So something like this. All right. So the cross-sectional area would be the shaded region, and that is 1350. And the height or thickness of the disk is this, which is 2 centimeters. All right. So the volume of one disk is 2,700 centimeters cube. So the amount of material available to make the disk is a million millimeters cube. Sorry. So that last one there is actually, this is actually millimeters cube. So the amount of metal that is available is a million millimeters cube, and one disk actually requires 2,700 millimeters cube. So to get the number of disk that you can get from the available metal, you have to divide. How many times can I get 2,700 from a million? All right, so we have to divide. How many times does this go into the disk? To find the number of, when dealing with multiple numbers of the same quantity, and they ask to find the number of, you have to divide. So it's 2,700, 2 zeros here, 2 zeros here, and the answer works out to be 370 disk. So from the available metal of 1,000 centimeters cube, you can get a total of 370 watt disk of volume 2,700 millimeters cube. All right, the B part of the question, and the B part of the question says, the B part of the question says, a globe is a spherical representation of the earth. And it says, is a spherical representation of the earth. The actual length of the equator, LL, is 40,000 kilometers, and it is represented on the globe by a piece of string of length 160 centimeters. What is the length of string? What length of string would represent the actual distance, an actual distance of 500 kilometers on the globe? All right, I normally do these questions like this. 160 centimeters on the globe is representing 40,000, is actually representing 40,000 kilometers. And now we're being asked is what distance, sorry, let me just read it specifically. Now we're being asked what length of string would represent an actual distance of 500 kilometers on the globe. All right, so the actual distance is 500 kilometers, and the length of string I don't know, so I call it x. Then what I would do next is I would cross multiply. So it's x times 40,000, that's 40,000. X would be equal to 160 times 500. Divide both sides by 40,000. That goes. X, which is the distance on the globe, or the distance on the on the globe. All right, two zeros here, two zeros here, a zero here, a zero here. Um, all right, we can do some more cancellation. 5 into this is 1, 5 into 40 is 8, 8 into 16 is 2 centimeters. So the actual distance of 500 kilometers is represented by 200 centimeters on the globe. All right, let's look at the second part of the question, the second and final part of this question. It says the distance between um, Palmyra P and Quintec Q is represented on the globe by a string length of 25 centimeters. Calculate the value of PQ, the actual distance in kilometers between P and Q. So go back to the initial information which we got, which is 160 centimeters is representing 40,000 kilometers. Um, then now this is 25 centimeters on the globe, so we put the 25 centimeter over here. I don't know the actual kilometer distance, so I'm going to call it x. Then I'm going to cross multiply. So this should be 160x is equal to 25 times 40,000. Divide both sides by 160. And now we end up with x is equal to 6,250 kilometers. All right. So 25 centimeters on the globe is actually representing 6,250 kilometers.